oxide, and oxygen is their reaction with nitrogen 2 oxide, where in the case of nitrogen 1 oxide, there is no evidence of reaction with nitrogen 2 oxide. But oxygen reaction with nitrogen 2 oxide give nitrogen 4 oxide. The distinctive tests to differentiate between nitrogen 1 oxide and nitrogen and oxygen is by reaction with nitrogen 2 oxide. Nitrogen 1 oxide reacts with nitrogen 2 oxide. In this reaction, there is no product formed, so no reaction. But in the case of oxygen reaction with nitrogen 2 oxide, nitrogen 4 oxide is formed in the process. So that is a distinctive test to differentiate between oxygen and nitrogen 1 oxide. Nitrogen 2 oxide is the second oxide of nitrogen. It is difficult to obtain the gas in the pure state because of its affinity for oxygen. How can it be prepared in the laboratory? It is prepared by the action of triazonitrate 5 acid on most metals such as copper. And the equation of the reaction is this: 3 moles of copper solid plus 8 moles of HNO3 aqueous gives 3 moles of copper nitrate aqueous plus 4 moles of water plus 2 moles of NO, which is nitrogen 2 oxide. So this is the equation of reaction of the laboratory preparation where concentrated HNO3, as is triazonitrate 5 acid, reacts with copper to give nitrogen 2 oxide as one of the byproducts. Nitrogen 2 oxide, physical properties. It is a colorless and poisonous gas. It is almost insoluble in water. It is slightly denser than air. It is neutral to litmus. Chemical properties. Reaction with oxygen. It combines readily with oxygen at room temperature to give bright or brown films of nitrogen 4 oxide. And this is the reaction to justify that nitrogen 2 oxide gas, 2 moles of it, combining with oxygen gas to give 2NO2 gas. This is brown fumes of nitrogen 4 oxide. That is the reaction of nitrogen 2 oxide with oxygen. Action of it, it decomposes to its constituent element on heating. On heating of nitrogen 2 oxide gas, when it is out, it decomposes to nitrogen gas and oxygen gas respectively. So that is the action of it on nitrogen 2 oxide. The third chemical property is reduction by hot metals. It reacts with hot metals such as copper to give copper 2 oxide and the constituent elements. In that situation, when you have your nitrogen 2 oxide gas, 2 moles of it reacting with copper, which is a hot metal, it gives copper 2 oxide. Copper 2 oxide and the constituent gas, which is nitrogen gas. So this is the reaction of nitrogen 2 oxide with hot metals such as copper. Test for nitrogen 2 oxide. the distinctive test for nitrogen 2 oxide is by pouring a solution of iron 2 tetrasulfate 6, which has been acidified with little dilute tetrasulfate 6 acid, into a test tube containing the unknown gas. If the solution turns dark brown, then the gas is nitrogen 2 oxide. The reaction to justify this is iron 2 tetrasulfate 6 reaction. If the gas is nitrogen gas, nitrogen 2 oxide rather, then it will, in the presence of concentrated HNO3, H2SO4, it gives this compound, which accounts for the dark brown coloration. Nitrogen 4 oxide. It is a reddish brown gas. Laboratory preparation. Laboratory preparation. On heating strongly lead-2 triazonitrate 5 crystals, it decomposes to lead-2 oxide, oxygen, and nitrogen 4 oxide. So the reaction to justify this is lead nitrate. This is lead nitrate. The 2 moles of lead nitrate solid, when heated, it generates lead-2 oxide plus oxygen plus 4 moles of nitrogen 4 oxide. So this is the reaction to justify the decomposition of lead-2 nitrate to the respective lead-2 oxide, oxygen, and nitrogen 4 oxide. Test for nitrogen 4 oxide. It is the only oxide of nitrogen that turns moist blue litmus paper red because it is an acidic gas. Properties of nitrogen 4 oxide. Physical properties. It is a reddish brown gas. 2. It has an irritating and is poisonous. 3. It turns damp blue litmus paper red. 4. It is much heavier than air and can be poured downwards. That is, it is delivered downwards. Chemical properties. It decomposes on heating to nitrogen and oxygen. What am I saying? NO2 decomposes to nitrogen and oxygen. So it decomposes to nitrogen gas and oxygen gas. This is the way it is decomposed to the respective gases. Reaction with water. It reacts with water to form mixtures of dioxonitrate 3 and triazonitrate 5. What am I saying? When nitrogen 4 oxide reacts with water, it forms dioxonitrate 3, which is HNO2 plus triazonitrate 5, and these are mixtures of acid, and these are mixtures of oxides too. So one of the properties of nitrogen 4 oxide, it has a tendency to form mixtures of oxides. Questions designed for this topic. Question number 1. Nitrogen combined directly with metals except A. Copper, B. Magnesium, C. Calcium, D. Aluminium. Based on the options, the only one that nitrogen does not combine is the transition metal, which is copper. Every other metals, copper combines with them to form their respective nitrides. Therefore, the answer to question number 1 is copper, because copper is the only transition element in this respect. Question number 2. The oxidation of nitrogen in magnesium nitride is A -3, B +3, C -2, D +2. Answer to this: magnesium nitride is Mg3N2. Our interest is to calculate the oxidation number of nitrogen in this. So here, the oxidation number of nitrogen, magnesium is +2 charge, +2. And since we have 3 atoms of magnesium, then nitrogen is, let's assume that this nitrogen is unknown. So 2 times N, that's +2N. Then the algebraic sum of the compound is equal to